So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 206 and in this video we continue with our exercise, but this video, like I said in my last video, we make a special exercise where we learn reading code. And reading code means you read first the code and then you check the explanation or the examples if they match up with your understanding. What I mean with that concrete is, for example, I have here this web page. I will link this in the description, and I updated my last video because I forgot to link this web page there. And what you have to do is, for example, you go here to the bubble sort. Instead of reading now the description and how a bubble sort is working, you go directly to the source code. For example, you copy this one. Let's copy this one. Let's paste it here. And now we try to understand this bubble sort just by reading this code here, how it works. And our goal is not to understand all things in detail. Our goal is to understand the general principle, right? And let's get started. But we make also a repetition of all keywords. That's why I will go over the keywords again. Because we are starters, we need to repeat a little bit. But yeah, let's get and see what we get out of this code. And when we finish this one, we will have an understanding, and then we will compare this with this explanation here. All right, let's go in. First of all, we have here include IO stream. I know this is clear. This I include here. We have not talked what it's doing in particular, but we know this include IO stream make it possible that we can use the C out, right? Or C in. There has some libraries. All right, that's cool. Then we are using namespace as today. We have talked about this one too. This is in general bad because we are using more the scope resolution operator, which means, for example, this double colon here, and then we are saying what we need. And this one many starters use, or also some advanced people use this as well, but they know then if this can cause problems or not. But if you use this one here with this colon, then you don't care about name conflicts, so it's better. Okay, that's interesting. And interesting is also here they have they put all the code in the function main. Normally when you create a sort function, for example a bubble sort merges, you make here a special function so it's encapsulate and it cannot conflict with other parts. So that's a little bit strange, but okay, you can make here the code. Okay, let's get started and see what they do. So first of all, they declare here 3 int variables, and you can see they use here one line declaration. And they initialize it not with default values. Normally it's better to initialize this with normal default values. And for readability, you can go to the next line as well if you want and declare them line by line like this one. And yeah, and so on. But let's keep this, what they got here. They got this one here. Let's keep this and go on. All right, they use one line, but you as a beginner, you have just to understand this one here. All right, then they declare another variable here, and this variable is just an array. They are declaring here an array, right? So we have here 3 variables and an array variable, and like you can see, bad naming, but this is just a demonstration of a concept like a bubble sort. And like I said in other videos, in real projects never use a name like this, a short name. It must be descriptive. But yes, we know this is just demonstration purposes. It's not used in real projects. That's why they use this A. Like in CPP reference.com, they use also all time the short name letters for demonstration purpose, but in general bad. All right, let's go on. And what we see here is they create an array with 5 elements, and they initialize these 5 elements here with this curly brace initialize list, right? We know this as well. So we have here an array. Let's make for demonstration purposes to make it visual a little bit an array here, and then we will use this one. So I create here a very bad array drawing, but it's simple. You can see 1, 2, 3, 4 and 5. This is my array, And let's make it. So this is the array and it has 5 slots, right? This is exactly here. This one here I make just for visualization. We will need it perhaps. Let's copy this one. Control C. Let's paste this. Perhaps I need more. I will see later. And then I can copy this one later. Okay, so this one is this array. And let's write the numbers here fast in it too. So I have here 10. I have here 2. I have here 0. I have here 43. And I have here 12. All right. and we know this is slot 0 because an array starts with slot 0. Okay, this is slot 1, slot 2, slot 3, and slot 4 of an array. This is very important that you remember this one because this will need this. You will need this later in a loop. It makes it okay. Let's continue here. Okay, we understand this one. This line is okay. We understand also this is just an output. And this line here, we see a for loop. Here we are looping. First of all, okay, a for loop will loop through something or will calculate something. So here we can see the range. It says here e equals 0, which means they are using the variable which is outside. And most time when we created a variable for our loop, we made this one here. The difference is here, you are creating here the variable and here they are using this variable. So they are not creating here a variable. They are using the variable which was created outside. That's very important here to note. And of course they start with 0. And here important, most time you can start with what element you want, with number you want. But when you are looping through an array, like this one here, slot 0, the first slot is called slot 0, and that's why this I0 is very important because they are using this variable I to loop through this array, and they won't start with slot 0, and that's why this 0 must match this one here. I hope you know this one with arrays. We did this, and then it will start here and go here, and here we have the range of an array. It is less than 5, not 5. Why it's not 5? You can see here we have 5, but here we have less than 5, and the reason is we start with 0, right? In programming, we start all time with 0, most time with 0, let's say it so, and then we increment this one. All right, and then we print out here this array. Here they are using again cout because they are using here std, using namespace std, and then we go here taking every slot. So this one is just slot call when you see a and then this brackets and then the I here. This is just slot call. Slot call means not this one here. Let's make it this one. This is a slot call. I call this slot here, this AI, and then I print the element out, right? And I will print out then 10 here. All right. So this one is okay. And here what's new is this one is this T. The T is what here? This is something new. So when I start this program for test purposes, you can see this T means here tab, and tab means just a special space here, this tab space here, and this is something we already know, this \n here, right? That means new line, and \t means tab. Okay, that was new. And we have checked the code till here, I think. And when I start this one more time fast, you can see this part here is just the part here. So far it is checked. It's okay. Let's go on. Then we make a end line. This is a special call which is the similar like a new line. We used in our tutorial all time this version here, but of course you can use the same thing with single quote like so. This one you will see also probably much time, or you can use this end L. End line is actually also from the standard library, so normally you would see this one this way, and you can see this one is a function end line, make a new line. So you can use, there are different versions and they are not exactly the same because this one is not flushing, I think. Yes, we have to read a little bit more in detail what they are doing behind the scene, but in general they are doing the same thing. They are going to the next line. In this case, that's okay. All right, so I think we understand then this part as well, and we go here to the main part because this one here on bottom is just again an output. So here we have here again, let's go here first. This one is just screen output, and this one will put, you can see it's just the same loop like here. This one and this one is the absolute same to print out this loop. So in this code, if you understand this part, you understand what this bubble sort is. So we have just to understand this one, but let's go into this one and we see a for loop, but a nested for loop. And nested for loop is not easy to understand because we will see in a moment why. Because nested for loops have many iterations and they, yeah, it's sometimes difficult to understand, depends what it is. But there is a very simple rule in nested for loops. Normally, you start all time with the innermost loop. What I mean with that, when you see here 2 loops, you have just to go to the innermost loop, and this one will finished, and then it goes to the auto loop, and the auto loop is then incrementing 1 up. You can see it starts here with 0, then it will increment 1 up, and then you go again to the inner loop, and then you finish this whole thing. And then you go under, or if it's finished with all this range here, you go up and then incrementing again, and then you go to the inner loop. So here, what you have to understand when you have here 2 loops, go all time to the inner loop, the most inner loop, let's call it the most inner loop. For example, you have here 3 loops, then you go also to the most inner loop and try to execute this first. So I hope you understand this. We will see it in this in a moment anyway. All right, so what I have to do, I jump to the most inner loop, and because here is probably that what you want to execute. All right, so let's jump to it. So this most inner loop, say here, I start, this is our condition for a for loop. We know this, we have a start condition, a range condition, and an increment condition. All right, we know this, we have talked about it. But interesting is this start condition here. The start condition says here, G, what is G? G is just another loop variable. This is here used for this loop variable in this loop here. And I is used for the other one. So we have a distinguish variable name. That's very important. Okay, but this G is calculated with yes, it is related to the I here, so it depends on I what this G becomes here, and that's already a little bit yeah, irritating, but we have to understand this line here. So try to understand what this makes. It takes I, the condition, and then it will add 1. So in our array example here, what it means is G is I, and here we have to go back to this first loop. And I said you start with the innermost loop, but of course when this one is connected here to this I here is defined here. So we see what the I here is. It is here related to this one, and that makes it a little bit complicated, but not too much. We see this I is here defined in the first step 0, so we can write it. Let's write here a little bit. All right, so we have here I, let's write it. Yes, here I is 0 at start, and this is the auto loop, right? We are not here. We are using the inner loop here, which is G, and G is calculated. Let's calculate G here. We start with G as here, and G is what? G is I plus 1, so say 0 plus 1 is 1. All right, this is this one here, and now that was it actually what we have to do because now G will go till less 5, and till less 5 means what means till less 5? Till less 5 means just till it reaches this element which is less than 5 and then increment. But we are not finished. What is the meaning of this one here? Let's watch this again a little bit closer. Okay, I think that's all thing what we have to do here. We have to go to the next line. Interesting, I forgot to mention this one here, this style here. You can see the scope here. Sometimes they put here the curly brace here, but this is just style. I like it more here because I see then instantly the scope, and they do this here as well. So let's continue. So we found out I is 0 and G is 1. And we are now here in the inner loop. And now this one is finished. Not finished. We understand all what happens here. And we are here in our first iteration. And now we have just understand this part. And we understand bubble sort almost. Not full, but almost. So let's see what happens here. We have an if condition, and this if condition says, first of all, what is our if condition? Our if condition is a check, and only if the condition here is true, it will do something. So with other words, if this condition is not true, it will not even go here, and the loop is just going to the next iteration step. That's very important that you understand this, because it is important what this condition do here. That's very important. So we have to check now this condition. So AG, what is AG again? Let's take it and see it. Let's go here. AG is A is our array. Let's write here. This is my array A. Let's say this is my array. Okay, and I have put in the numbers 10 to 3. Here are the slot numbers. Yes, and now AG means a array. A slot G. G is right now 1, so I jump here to 10. All right, must be, so condition. We are writing now the condition. Let's write the condition here. Something like this. The condition is this AG, which is the 1, slot 1. Let's make it here. This one must be less. Here's this less sign. AI. AI is, what is AI again? AI is 0, which is slot 0. All right. AI, important here is that you not confuse here the value with the slot. Slot is this one, value is this one. And the value of I is 0. It was defined here. And this is sometimes very confusing, and careful about this when you are trying to go through these loops. All right, so I is at the moment 0, the value of I, and I put now in this here, which becomes the slot AI, which means A slot 0. And this is this one here. This one becomes this one. Can you see it? Don't confuse here with the values here sometimes. And if you understand this, then you understand how this works. Condition, this is very confusing in arrays sometimes, these values. So, but yeah, after this one, let's continue. Let's say we understand this now. And what we can see here is very important. You compare the right side, right? This AG is all time the right side here. So this you can see this loop. This is this loop body, right? This will come all time here in this place here, because we loop here all time through, and it will all time compare the right side here with the left side here in the first iteration at least. So in the first loop iteration. So what happens is here, let's see what happens here. So I mean, this is the condition, sorry. This is the condition must be true. So the right side is now 2. So now I say, okay, the value 2. This is AG, is the value now. Now I take the value here. Must be less than AI. AI is the slot. This is AI is the slot 1. And this is 10. And if this is true, this is this one here. I will go what? I will go into this body. If this is not true, I skip this whole thing and then go to the next iteration. But here in this case, this becomes is true. This becomes, yes, it is true. So we are entering this if body, right? Okay, we're entering here because let's say this is true. True. Because this one becomes to true. And because this one becomes true, we are entering, and now we have to understand just what this if body is doing. And let's see what the if body here is doing, and let's make here a little bit more space perhaps. Let's put this one a little bit more down. So now I have more space. So I enter here the if body, and what it's doing, this temp here was just a normal variable, is assigned with AI. And AI is what again? AI is the slot, but when you are using it this way, you are accessing the slot. So A is array, I is right now 0, AI is slot 0, and you are getting the value of slot 0, which is 10. So you are doing here assigning 10 to temp. All right, so let's write this down. So what I do here is assigning temp equal 10, and this one here is directly, but here is just array accessment. All right, the next line, what is doing the next line? And careful about this, you can see here we are getting AI, and what we are doing is now we are assigning our value to the slot AI. So what we are doing is, again, we are writing AI here, AI, but now we have to write I value. Not write here AI, we have to write the AI value. I is 0. Okay, A0 means I'm going here to my array, I go to the slot 0, which is here. And what I'm doing here now, I'm assigning a value to this one. So with other words, I erase this value here. Let's erase this. Yeah, we are erasing at this one. Let's go with, because this one becomes a new value here. And this new value is AG. So what is AG here again? Let's do this one. A is again our array, and G is our G here. So AG is actually, yeah, we can write here. You can write here A, for example, this one here, G1. And A1, then you get the value from this one, which is 2. So this one is 2. So we can write, instead of the place here, this is the slot version, and in real you are doing this one. You are getting the value 2 and assigning to the slot AI, right? So you get the value from here and assigning it to this slot A0, and this one becomes here our 2. So let's do this. We get here a 2. All right, this is now the 2, which is swapping from here to here. All right, that is okay. I change now from here to here, and let's see AG. What is AG? AG is this part here. So AG, what was G is 1. You can see this is just to find the slot number. A is array, G is 1, so you follow this one, A, slot 1, and this one 2. And what I'm doing here again is I assign to this slot a new value, which means I erase again this value here. Let's erase this. All right, and what I'm doing here, which value I assign their temp. Temp is 10. Right, I assign here temp. You can see I assign here temp, and temp is here 10. So I assign 10 here. So what we did here is, and you can see we swapped here these values. So this little function here is a swap. We swap this one and this one, and we can write this here directly because this is now our understanding. This little function here, or this little code here, let's say so, not function. This little code here is just a swap. But important is this little swap here will only swap under this condition. This condition is very important. Let's write here swap condition. And this is one understanding, a part of the full understanding of this code. We are not finished. Now we have to understand the iterations, which means we have now understand the loop. What is the loop now doing? We understand what the swap is doing. So the innermost body, we understand what this is doing. And now we have to connect this with the loop. What is the loop doing? And we start again with the innermost loop and do this. And we know if this is a swap, this one will now all time try to swap when the condition is true. And because loop means you do this one here over and over and over and over again. All right, we understand that. So, okay, this loop will try to swap all time now. But careful, we are not finished, because what is here the problem? You must understand, how does it try to swap it? If it swap it now here, where it is going here after this one. And that's very important that you understand now the loop, and that means that you understand this g plus 1 and with this g plus plus. So g plus 1 starts here. So let's make here this g. Where is my g? So g starts here, right? For the first loop. The second loop here, g plus plus, means I add to this g what I have, which starts here, one more, which means it goes here. So the next g is here. And then the next g will be here. And the next g will be here. Because this g plus plus, it started here, very important, it started here and it goes here. And the next thing what you have to do is understanding the condition. The condition says here, I will check all time ag, which means ag was, let's write here this a little bit better, because this one here is ag. Let's write here ag, because here is ag, this one here, right? This is our ag must less than a I, which is our swap. But careful, look what happens here. And this can irritate some people, and that's why we are doing this one. This ag was here, is now here, right, in my second iteration. And you can see this g, the first one, compared to this one, and then this is the condition. And then if the condition is true, then I go here to swap. But if the condition is not true, I will not swap. In the next loop here, this j is here, and what it do is not comparing with this one here. This j here, ag, is comparing still with ai, which means it's here, the first one, right? You can see it. It's still comparing to this one here. And the next one will compare again to this one here. And the next one will compare again to here. Because this I here, AI, is our outer loop. And like I said, this outer loop will wait till this loop is finished with its range. And this loop will finish with its range till this j is through the whole range which it's allowed to go, and it's allowed to go here. After this one, it's finished. This AI is, and now before it's finished, we have to understand what does this AI, what is the function now of this AI? What does this loop? The loop did this. First of all, we noticed it swapped two values, which is the right one with the left one, that we already saw here in our swap menu. All right, then we saw it swapped it only under this condition, and that is the new thing which we have to add. It is moving this g to the right. You can see it here. From here it moves here for every loop iteration, and then it compares with the first one, and it will swap only these two values if the right one, which is this one, all time it is what? Like it says here, this condition says is ag, so all this g's here must be lower than the first one. Then it will swap it. So which means, in our case, let's try to understand this first. Theoretically, it's a little bit hard, but let's try it. First, do I swap the first one? ag is the 10. And AI is 2, is 10 less than, is this right? Oh no, that was already the swap version, sorry. This is not the original, that was already the swap version which I have. So the first version we already swapped, because 10 was here at start, you can see it was already the swap version, sorry for that. But let's go to the second place. We have swapped the first, okay. Let's go to the second. Then it compares here g with the first one again. So 0 with 2. Will this swap? 0 with 2, yes, it becomes true, because 0 is indeed lower than 2, which means this 0 and 2 will swap now too, and 0 stays here. What happens next? Next, it will go here to this g, which is 43, and 43 will be compared to the first one, which is 0. But I think 0 is all time the lowest one, so it will not swap. And then it goes here to the 12, and 0 is still the lowest one. It will not swap because this becomes never true, because 0 is the lowest number. This will become never true again after we have 0. So we can see this loop here will all time swap the lowest number to the right side, to the left side, because you can see here the arrows. They check all time the left side. So this was the first, when we finished the first loop inside the inner loop. And now we have to go one step more. So we see the lowest number will be put on the left side after one iteration. But what happens with the other loop, the second loop? The second loop is changing only one thing. What is it? It changed just the I here becomes, let's make this I1. So when this one becomes I1, what is the changing here? Actually, not much. The only thing which change is it starts not here. The whole thing what we discussed here starts again, but from this point here, because I is now 1, which means I becomes this place here, and G becomes then this place here at start. And it is doing the same thing like here, only shifted one to the side here. So from the first loop started here from start, the second loop here, when we go to the other outer loop, it will do the same thing like the first one, but just starting, let's make me here another color here. The second loop will start here, but will do the same thing, right? Let me make it perhaps here down, because that one looks very, oops, because that, oh, what's that? Don't know what that is. Sorry. Let's see here. But I think you understand it, right? Or it can take here a very nice thing. No, I can't. All right. Anyway, you understand it. The outer loop is just shifting here. Yeah, it's just shifting here the place. It goes from here. So it goes from here to here and do the same thing. It goes from here to do the same thing. And our conclusion is that all time the lowest number is going to the left side, because this one is the most important part, this G here, if you understand, because this G here is this part here, and the other one is and this part here is how the loop is going through this array. And the loop is going here, first this one, start with this, go through, then start with this, go through, start with this, go through, start with this, go through. And all time, the lowest number you can see here in this innermost function here, which is our G, will go to the left. The lowest number will go to the left. And we have to check this. How we can check this? If this is true, very easy. And not very easy, I already tested it, so but for starters it's definitely not easy, but the nice thing is it's easy to change your one value and you can check it. So I show you this. So what you have just to do is the auto loop will only loop one time when you set this to 1, because when you set this one here to the range of 5, it will loop 5 times, but when you set this one to 1, then you have your loop one time, and one time will this loop here, and then it stops, right? So that's why I said it's easy, but not easy to understand. But let's start this one. And in my first try, you can see now I have an output. This is the original number, right? And my first array says the lowest number which I found in my first iteration is 0. And at that one I showed you right here. I hope you saw this. Let's compare this one here side by side. You can see here the lowest now G was, where is that or not? So let's compare it here, put it here perhaps. So you can see it, okay, yeah. So let's see what we have here. So again, we go here to the condition. That's very important. Here starts the action, right? It says AG less than AI, which means here the first number. And at start, it finds actually the number 2, but this one we can't see. Why we can't see two here? Because this here, the output what I have here is finished with the whole loop here. So whole loop means here, oops. Whole loop means here, you see here the end product after it is go through all. And through all, when it goes here through all, it will try to find in this iteration the lowest number. When it checks here, okay, when I check this number is 2. When I check now 0 and 2, 0 is the lowest number, 0 goes here. You can see 0 is now here at start. Then 43 and 0, no, 43 is not lower than 0, you stay. And then 12 and 0, no, 12 is not lower than 0, you stay. And we check the first iteration. And you see, yes, we understand it. All the lowest number are going to the left side here. Right, the lowest number. And then when you check now the next number, for example, I said you can just go for the next loop, outer loop. Now I make the second iteration, the second one, and I start this one, and let's see what happens now. And the second iteration here means, okay, I try to find the second lowest number, because now I shift here, like I said, the auto array is just changing from slot 0 here to slot 1. Now we start here. We start here now the whole thing here again with slot 1, what we did here. And again, we check all this time with this place here. Instead of with the first one, we check all with the second one, because we found the first lowest number, which is 0. So, and what it does is, okay, here it was 10. You can see it was 10 here, but this 10 here will be replaced probably with, I don't know, what's this 10 here? No, it was, I don't know. It will replace anyhow with the lowest number here. You can see the lowest number here in this remaining here is 2, right? Because the first one, the 0, we found already here. We found already the first iteration 0, and then this other are remaining. And this one will find now the first number, and how it's finding it, all time on the left, right? It goes all time to the left. That's very important here. And then we have this 2. And in the next iteration, we will have only this numbers here. You can see this in the next iteration. So when we go here to E3, we have only these 3 numbers available, and I can say you it will find 12 here in the middle. So because now I understand the code a little bit. In the next iteration, I expect that this 12 is here, because it's all time going to the left side, and this one we already found. All right, let's test this. If we see this anyhow, and we start this, and that is all time worse when you see something like that. But I was right anyhow, right? So you can see 10, I found 10 here. That was the next lowest number from all this. And now we have this 2 left. In the next step, when I go to iteration 4, it will find 12, that this one is still lower than this one. It will swap this one here out. All right. I think you get this, and I think we understand this code now without explanation. Of course, in this video I made it a little bit fast, but if you do it on your own, you will take much more time, probably. That's normal as a starter, but you should just try to understand analyzing code and trying to understand it, what it's really doing, right? That's the point here. And with that said, I can make, let's start this code first. I can make a description now of this code, what it's doing. I can describe this code on my own words without reading any other description. And you can see the last one is here swapping, and we have our final ordered list. It is ordered, and now I can describe how this code is ordering. This code is ordering all the values with the lowest number on to the left side. So that is my conclusion, or let's write it. So I make it not here a big conclusion now. Normally you would make it a little bit more detailed, but my conclusion, this code is ordering numbers to the let's say, so this code is ordering the lowest numbers to the left side. So something like that. Yes, what I mean with that is it's not a very good description here, very bad one, but the lowest numbers, it's our all-time order to the left side till the loop is finished. Right? We can see it here. We saw it here in this way. Here, this color brown color demonstrates the best way. All time left side check, and after all time I check, I will put to the left side the lowest number, and then I iterate through. So this, let's keep it so simple. Let's, of course, you can go here deep and analyze it more and more, but let's see now the final step. We are not finished. This one here is my understanding of this code here, and yeah, it is ordering. It is a sort, and let's see if this sort matches with the description what they have here. And to see if this is true, we have to read a little bit, because I know what the code is doing. I saw it, I analyzed it, I get it. So here it says bubble sort is the simplest technique in which we can compare every element with its adjacent element and swap the elements if they are not in order. Yes, the swap thing here we have found, right? Swap the elements if they are not in order. Yes, I found this. That was this part here. Here we have our swap. We have here our swap condition. This way, at the end of every iteration, yes, we have iteration because we have here the for loops, double for loops. Every iteration, it's not exactly described, of every iteration called a pass. Okay, they have a special name here. Like I said, this sorts here, this sorts which you can see here, they are well known sorts and for beginners made, so you can study them and try to understand them, and they will be used also in different places. And let's go here a little bit more, because here you have more information that I can give, called pass. The heaviest element gets bubbled, and now we have this word bubble. Here is a bubble sort. So the heaviest element. What is that? It says the heaviest element gets bubbled up at the end of the list. Wait a minute. Wait a minute, my friend. That's not the description what I have, at least what I have found, right? We found out that this code here, what we have here, at least when I made it right, the lowest element goes to the left. Or perhaps my English is bad and I don't understand this one, but let's read it again. It says here, the heaviest element, the heaviest is probably the biggest number, because the heaviest element is not the lowest number, right? Gets bubbled. Bubbled means bubbled up to the end of the list. The end of the list is clear. End means here. This is this side here. And the heaviest element goes not bubbled up anywhere. In my code, what I have here, we are checking all time the lowest element, and it goes not to the end, it goes to the start of the list here, of the iteration. So this description here match absolute not with the code what we have here. Or let's see, perhaps I made a mistake. Here's an example what they made. Let's see what we have here. So they give here an array to be sorted. All right. We have also an array in our code which we sorted. Okay, we have it here. Here's another array. And now they demonstrate this. So they say, okay, the pace one, which they called here. All right, this is this first block here. Okay. And then they say here, okay, this one are checked. Yes, we checked this too. This is this check function, no worry. And they say now, after they check this one, the heaviest element go to the right. And when I check this one, indeed, 45 is the heaviest element. This stays here. Then they go to the next loop. This one here, what you see here is one iteration. Oops, sorry, not this. This one array here is one loop iteration. Okay, the next check here, they go here again, and you can see this 45 is checked now with the right side. interesting. We have all time checked here with the left side. So we have not checked with the right side. Here you can see this one is now anyhow, or perhaps I'm wrong. Perhaps they take here and check this one with this. Could be also. Perhaps I'm wrong here. But anyway, important is they are checking now 45 with 8. That means they take here really the biggest number. And then they swap it if this biggest number is bigger than the right side. When I see this, right? You can see this in the next line. The biggest number is walking from left to right here, right? And in the next iteration, the 45 is here. And here in the last iteration, 45 is here. So with other words, they are describing here something, not that what the code is doing. The code is not doing this. The code is sorting. Yes, sorting are actually not only this code, the other codes are sorting too. But the description what we have here, which is bubble sort, and this interesting is this bubble sort here is, I think it's really described, but the code is not a bubble sort code. Because this code what we have here is doing what? When we watch this, you can see the heaviest element goes to the right side. In our code, when we check this one, the lowest element goes to the left side and it gets sorted. So it is a reverse bubble sort, or a reverse version of a bubble sort, but it is not bubble sort. So what they described here, and that is, I think, that is my conclusion, which means this is a problem. And interesting is this site here faked me too, because I thought this was made for starters. And when it's made for starters, you normally can copy this code and hope that this match with the description, but you can see this is not the case here. This website presents us a wrong version of a bubble sort. It is a reverse version. And if you go here and trust now this kind of code, or any code what anyone presents you, and you integrate it in your code, and the iteration steps, let's say the iteration steps are also very important, then you will mess up, right? You will have a problem, because this one is really when you think about it, these two codes what we have here, this one, the heaviest element, which means in this case the biggest element is going to the right side. In our code, the lowest element is going to the left side. So it is really a reverse version of that what they describe. And this, sometimes you can think, okay, but it's similar, the same principle. You can't say this in programming. Why not? Because yes, these are all sorts, because they do all the same. They are sorting, but they are definitely not the same thing. And that's why it's very important that you should distinguish between things like that. If anyone say, I want a bubble sort, and you are presenting now this code here, you should be, probably you get 0 points because this one causes problems. This is not the bubble sorts per definition, right? That's very important. It's the definition and the code is not matching. So I will stop here. And interesting is, I thought this website, because I said I was faked, I thought this website made it right. So I want, I don't know who is, I hope this website is realizing that and correcting that perhaps soon. If not, no worry. We can test here the other codes as well, because now you can see this. Now you should test this other codes more in detail. Probably they give you not, perhaps you are lucky they give you a good description what this selection sort, insertion sort, or quick sort is, or you are unlucky like here. They describe it right. For example, in this case, they described it right. I have no bubble sort already, but the code here is not a bubble sort code. Sometimes it can be the other way around. The code is a bubble sort and the description can be wrong, and that's why it's very important. So like I said, try this again with, let's say, one more, because that takes a lot of time. And but try this one more time with one of these other sorts here. Probably this quicksort. Try this quicksort, or because quicksort sounds very nice. Quick means fast. It's all time good, right? We want something fast. And yeah, try whichever you would like. But I think I will go for, do I do the quicksort? Oh, that looks a lot of programming. Yeah, we will do this quicksort. They use here pointers. We make a little pointer and arrays again. Yes. We make here a little bit point and array training, because we are training here, right? So try to make this quicksort here to understand it. Again, don't read the description. Read the code, try to understand it, and then read the description. You see, the code here did something else than what the description does. The code here is not the bubble sort which is described here. All right, with that said, I stop this video. I hope you learned something and you tried it on your own, because that's very important. And with that said, if you have any suggestions, comments, like all time, write it in the comment section. See you in the next, where we will talk about the quicksort, if this is right or not described in this website. Bye, and see you in the next. Good luck.